Hello everyone, and welcome to virtual lab at Vivekananda College of Engineering and Technology, Puttur. It is V Lab at VCT. In today's session, we'll be discussing about op-amp as inverting amplifiers. Now, basically, the op-amp is called as an operational amplifier, which is used to perform different mathematical operations like addition, subtraction, integration, differentiation, and so on. It is a high gain differential amplifiers, which is mainly used in different type of circuits like amplifiers, oscillators, filters, and so on. It is one very important component for the construction of any electronic circuits. The commonly used on the op-amp is IC741. This is 8-pin IC, which is having two inputs. It is inverting input and non-inverting inputs, and one output. So first we'll discuss about the symbol of an operational amplifiers. Then I'll be discussing about the circuit diagram of an op-amp as an inverting amplifiers. Then we'll implement that circuit using a virtual lab. So this is a symbol for an op-amp. Here, as I mentioned, it's having two inputs. That is, one is the non-inverting input, another one is inverting input. Non-inverting input is denoted as the plus sign, and the inverting input is denoted as a negative sign, that is minus sign. And if I'll give an input signal to the non-inverting input, then output will be non-inverted version. The output and input are in the same phase. If I'll give an input signal to the inverting terminal, then output will be inverted version of the input signal. And it requires a dual supply to operate, that is positive power supply and the negative power supply. Okay. So this is about the op-amp symbol. And if I'll consider the IC741, that is a 8-pin IC. Here the pin number 2 with the inverting terminal, and pin number 3 is a non-inverting terminal, and pin number 6 is output, and pin number 7 and 4 is used for a positive power supply and negative power supply. And we'll be discussing about the op-amp as an inverting amplifier. So this is a circuit diagram for an inverting amplifiers. So the amplifier is a circuit which is used to give a strength to the signal. Since the weak signal is given as an input, and output will expect a large signal. And the amplifier can be constructed by using transistor circuits or using op-amps. Here, by using op-amp, we can construct two types of amplifiers. One is inverting amplifier, the other one is non-inverting amplifier. So this is a circuit diagram for inverting amplifier. So the input signal is given to the inverting terminal of an op-amp here, and the non-inverting terminal is connected to ground. The two resistances are used. One is R1, other one is RF. So R1 is the input resistance, and RF is the feedback resistance. These two resistances will decide the gain of an circuit. So gain indicated by the output by input. And as I mentioned here, this is an inverting amplifier. So output and input is out of phase here. It is an out of phase. So AV is equal to minus RF by R1. So the output voltage will be given by AV into V. So in this circuit, I'll verify the output and the gain of the circuit. For that, I'll consider different values of R1, and RF I'll keep it as fixed. So RF is 10 kilo ohm, and R1 I'll vary from I'll take 5 kilo ohm, and the RF is 10 kilo ohm. So the gain is expected as minus 10k divided by 5k. So you get that's minus 2. Similarly, I'll change the values here. The R1 is 2.2 kilo ohm, then 3.3 kilo ohm, and 10 kilo ohm. So the corresponding output voltage is here minus 4.54, and the gain is also same. It's minus 4.54. Similarly, if I'll connect to R1 as 3.3 kilo ohm, then the answer will be minus 3, and if it is 10 kilo, the answer is minus 1. Okay. So in the circuit, I'm having the operation. This is the op-amp. It's an op-amp. It's a symbol for an op-amp, and the two resistance R1 and the RF, and I require one more source, that is input source. I'll connect here input source as a DC voltage. So you can give a AC signal also. If I'm giving AC signal, you can expect a non-inverted version of the output here. Okay, so the output equation is the gain into P. V into P. Now I'll implement this circuit in a virtual lab. Okay, so the advantage of using the virtual lab is so I can check the output for different values of the resistance and input voltages. If I'll rig up this, implement the circuit in a real laboratory, then for every component, you have to change the circuit and you have to check the output again and again in oscilloscope. So instead of that, here if I'll change the values like R1 from 5 kilo ohm to 10 kilo ohm, and I can vary at the same time, you can vary the input voltage also, you can note down the corresponding output voltage. So you can, similarly, you can verify the different circuits. Okay. And to implement this circuit in a virtual lab, so I'll go to the virtual lab, that is cells.vct.puttu.ac.in/circuits vn, enter. So this is the home page for the virtual lab. So here it's mentioned VLab at VCT. Okay, so there are different options, home, about, and virtual labs. Just click on this virtual lab. So you can observe this is a window. Here we are implementing the circuits. So initially some demo circuits will be displayed here. If I want the full window, just click on this option. Window. So you'll get this. Okay. Now, to implement this circuit, the op-amp has an inverting amplifiers. Okay. So there is option like circuits. Say there are many options at the file, edit, draw, scopes, or options in circuits. To implement any circuit, just go to circuits. So here you can observe there are different options. Are there basic circuits like check the Ohm's law, then check the resistors, voltage across the resistors, capacitor, AC circuits, passive filters, and many circuits are there. Okay, some demo circuits. So if I want to implement the inverting amplifiers, I need op-amp. Before that, I'll just go to a blank circuit. Okay, so get a blank page. Go to circuits. Click on this op-amp. I'll select op-amp. So this is the symbol for an op-amp. So here it is mentioned +3 and +4, and output as 50 node. So I want a basic op-amp, so I just delete this. Yeah. So I selected op-amp. Next, to implement the circuit, I need two resistors. So I'll go to this option, draw, and here there are many options like add bio, add resistor, passive components, input and out sources, output labels, active components, and all. Many components will be available in this. So I need two resistors. So resistor is a passive component. So here add resistors. Just click on this. Now place one resistance here, that is R1. Similarly, place one more resistance. This is my RF. Okay. Now, next I need the input voltage source, that is a DC source. So I'll go for input and sources. I'll click on this add voltage source to terminals. So I'll place the input voltage here. Okay, input voltage. Then I'll use the ground. So you can use a shortcut option also, G here. Press G, you'll get ground connections. Ground. The ground. Okay. You can place anywhere in this page. You can rotate also the components. Just to hold on this, and you can rotate wherever you want. You can place the components. Okay, so these are the component which is required to implement my circuit. That is op-amp as an inverting amplifier. Okay, now to connect the components, I'll use a wire. So this W, and connect the component. Just place the cursor at this particular point and just drag. So this is connected now. Similarly, from this input to the resistance and still is connected to the resistance. From this point to connect it to ground, so this is connected. The negative of the input voltage is connected to the ground, and a non-inverting terminal should be connected to the ground terminal, right? And the RF resistance, this point, we'll connect the wire from resistance RF to the inverting terminal. Similarly, this output terminal, I'll connect it. The other end of RF resistance is connected to the output terminal. Okay, now in this I'll connect a wire to this output point also. Okay, so this is about the circuit connections. Okay, the component, this is my R1, this is RF, this is op amp is used, and here inverting terminal we are given the input voltage through a resistance, and the non-inverting terminal is connected to a ground point, it's a ground. Now the next step is the change the values of resistance. So by default it will take 1 kilo, but I need the input resistance as 5 kilo, and your feedback resistance I'll connect it as 10 kilo. So just escape, just double click on this. Okay, to change the values, so to edit the component, just double click on this particular component. You'll get this option. So just change it to 5 kilo. 5 kilo. Apply OK. Okay. So now the value is instead of 1 kilo, now it is changed to 5 kilo. Similarly, the feedback resistance change it to 10 kilo. 10. Okay. So now the value is changed to 10 kilo. And this voltage source, there's a DC voltage, make it as 1 volt DC. So this is 1 volt DC now. Okay. Now to measure the output, so you can use an oscilloscope. Generally, to check the output, to measure the output to voltage or input voltage or different values and all, I'll use oscilloscope or multimeters to check the output. So here I'll check the output using the scope. That scope indicates here oscilloscope. If even the scope will be displayed like this. Now I'll run the circuit. Okay. You can observe here. So initially the output voltage is 0, and I can observe here I given 1 volt and RF is 10 kilo and R1 is 5 kilo. So 10 divided by 5 is 2, and my output voltage is V0 is what? Minus AV into Vin. So AV is 2 minus input voltage is 1. So now I'm expecting output voltage as minus 2. So I can check the output at this particular point also. So for that, just go to this option, view in undocked scope. So this will be displayed over here. So you can observe here, this voltage at this particular point is minus 2 volt. Okay. Similarly, so you can observe here. So this is for a 5 kilo ohm resistance with the RF is 10 kilo ohm, I'm expecting output voltage as minus 2. Right. Similarly, if I'll change the value of R1 is for instead of 5 kilo ohm, if I'll make it as 2.2 kilo, then I should get output voltage as minus 4.54. So I'll make that changes in the circuit. Okay. So I'll change this to 2.2 kilo. Okay, 2.2 kilo, and resistance is 10 kilo. Just click OK, and I'll run this. You can observe there is a change in the output voltage now. So your 10 divided by 2.2 is 4.54 multiplied with 1. So we're expecting the output voltage is minus 4.5. See, as I mentioned, is minus indicates here the output is inverted version of the input signal. Okay, similarly, I can change this. Instead of giving a DC voltage, I can give a AC voltage also. So I can expect output also in AC, but it is inverted version of the input signal. So this is about the op amp as an inverting amplifiers. Okay. So similarly, you can construct an op amp as a non-inverting amplifier by giving a signal to the non-inverting terminals. Okay, I should give this input voltage to the non-inverting terminal, and this feedback resistance and input resistance is connected to the inverting terminal only. So you can expect output voltage in terms of positive. So in a non-inverting amplifier, we get output voltage is 1 plus RF by R1 into VA. So in this way, you can construct different circuits, so different analog circuits like amplifiers, oscillators, rectifiers. Okay, and you can note down the corresponding output by changing the different values of resistance or capacitance values. So this is an advantage of using the virtual lab with the compared to real amplifiers. Thank you.